Good morning. We're going to be talking about the properties of parallelograms today. This is lesson 45 and it comes out of section 6.2 in your book. I have a couple of review questions to start with. The first one is, what is a quadrilateral? And you should all know that a quadrilateral is a four-sided polygon. And my next question is, what is the sum of the angles of a quadrilateral? And I don't know if that we've really discussed this, but intuitively you should know, well, a square has four right angles. That adds up to be 360. So the sum of the angles of a quadrilateral add up to be 360. Today we're going to try to explore and use the properties of parallelograms. You know what a parallelogram is because we talked about that last week when we were working with area. A parallelogram is a quadrilateral and it has both pairs of opposite sides being parallel. So I have double markings here indicating this is the pair, single markings here. And so I have posted here in this lesson, when you mark diagrams of quadrilaterals, use matching arrowheads to indicate which sides are parallel. So when I look at that picture, I'm not confused about which ones are parallel. So in my diagram, AB is parallel to DC, AD is parallel to BC. We're going to be talking about a new symbol. This symbol stands for the word parallelogram. Not sure what just happened there, but this symbol stands for parallelogram. So instead of writing that big long word, I'm just going to put that symbol in front of the letters and it would be read as parallelogram ABCD. Now, in a quadrilateral, there's a couple of terms we need to talk about. What are opposite sides and what are opposite angles? Opposite sides do not share a vertex, and opposite angles do not share a side. So let's look at this next figure. Here is AB, and here is side DC. They don't share any vertices because they don't have the same letters in their names. So AB is opposite DC, AD is opposite BC. I think you know that intuitively. And then opposite angles do not share a side. So if I'm looking at angle A, it's made up by AD and AB. If I'm looking at angle C, it's made up of BC and DC. They have no sides in common, and so they're opposite. But intuitively, they're across from each other. They don't follow, so I can understand that notion of opposite. The first theorem we're going to talk about today is theorem 6.3, and it says, if a quadrilateral is a parallelogram. All of our theorems today are going to start with that. If a quadrilateral is a parallelogram, then its opposite sides are going to be congruent. And you're going to need to mark that in your picture. Your sides should be marked parallel, but now you're going to mark those opposite sides as being congruent. So we know that PQ is going to be congruent to RS, and PS is going to be congruent to the top side QR. Now I'm going through these really quickly, and at the end we'll try to work some problems. It says angles of a polygon that share a side are called consecutive angles. So when I'm looking at my picture, this angle and this angle share this side. Or consecutive just means to me they follow each other. These share this side, so they are consecutive. Now, I want to explore a little more about what's got to be true about the consecutive angles in a parallelogram, not just a polygon, but a parallelogram. So I have a picture here, and I have my opposite sides marked as parallel. Now, I've extended this side, and I'm trying to go back to that notion about what happens when parallel lines are cut by a transversal. Right here's my transversal. Here are my parallel lines. So there's an angle formed here and an angle formed here. I'm hoping that you can see that those angles are same side interior. They are between the lines and on the same side of the transversal. So in a parallelogram, consecutive angles are supplementary because they are same side interior. So that means the angle here and here, when added together, have to equal 180. If I know the measure of one of them, I can find the measure of the other, because we're going back to that notion we've been working with all year, two angles being supplementary. Now this is what Theorem 6.4 says. There's that phrase, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So as you move around this figure, any two angles that share a side are supplementary. P and Q, Q and R and S, S and P. There are four pairs of consecutive angles that are supplementary to each other. Now here's a little proof I just want to talk about. We haven't done a lot of that with our distance learning, but I just want to take a few minutes to do that right now. We know that the measure of P plus Q equals 180 because we just learned that in the previous theorem. Those are consecutive angles, so they equal 180. We also know that Q and R are consecutive angles, so they have to add up to be 180. I don't know if you can remember this. It's been a while since we've done proofs, but since these are both equal to 180, we can set them equal to each other. Some of us will call that the transitive property, and some of us will call that the substitution property. Since there's a measure of angle Q on each side, we can subtract that away, and we're left with the measure of P is equal to the measure of R. And those are opposite angles. And I just proved that these opposite angles over here, P and R, are going to be congruent to each other. Then if we look back at this geometry proof over here, we're doing this with geometry, not algebra. We learned a theorem back in chapter 2. If two angles are supplements of the same angle, they are congruent. P and R are supplements of Q, so they have to be congruent. So either way we want to go, with an algebra proof or with a geometry proof, we just proved that opposite angles are congruent, and that's our next theorem. If a quadrilateral is a parallelogram, then opposite angles are congruent. I have those marked in my picture, and you need to mark those in your picture. Q and S are opposite, so they have to measure the same. P and R are opposite angles, and they have to measure the same. You need to fill in your angles on your sheet. Angle P is congruent to angle R, and angle Q is congruent to angle S. If a quadrilateral is a parallelogram, then its diagonals bisect each other. That is Theorem 6.6. Now, please pay attention. I am not saying that the diagonals are congruent to each other. In a parallelogram, there's going to be a short diagonal and a longer diagonal. I am not saying they're congruent, but I am saying that when they intersect, each bisects the other. So right here, this one gets cut into two congruent pieces. This one gets cut into another pair of congruent pieces. But those four measurements are different from each other. So that is Theorem 6.6, and I know that QM is equal to SM and PM is equal to RM. I'm going to stop this video now and start another one where we are working through a few examples that use these theorems.